So welcome back to Explain 3, Modeling with Exponential Decay Functions. So here we're asked to, given the description of decay terms, write an exponential decay function. So here we're going to see how things kind of decline or go down over time, and graphing with a graphing calculator. So here the value of a truck purchased new is $28,000. And for any of you who are in the business of buying a new car, you'll notice that when you buy a car, whether it's used or new, it kind of decreases in value as time goes on because it's used. And in fact, this car will go down in percentage of 9.5 each year. So they ask us to write an exponential function and to graph, and to use that graph to tell us how many years the value will be 5,000. So that car that you bought brand new at 28,000 is actually going to be worth less over time. So the first thing we're going to do is we're going to pull some of these numbers. So purchased new, that's our initial value, is about $28,000. Whereas the rate, or R, is a 9.5, and what we're going to do is we're going to divide by 100 to change that into a decimal value. Go ahead and do that right now. You should have gotten 0.095. So we're going to go ahead and substitute those values in. So $28,000 for A and 0.095 for R, and go ahead and simplify this out. Go ahead and figure out what 1 take away 0.95 is. And that would be about 28,000, 0.905 to the t power. Alright, the next thing we're going to do, we have written an exponential function. We are going to graph it using our graphing calculator. So I'm going to go ahead and copy this down. 28,000 times 0.905 to the t power. And we're going to use Desmos to go ahead and graph that out and figure out at what point the truck will be worth $5,000. So I opened up Desmos.com on a separate screen. So I'm going to go ahead and type in our original equation. Instead of writing f of t or v of t or any of our function of time, I'm going to write y equals $28,000 parentheses 0.905 and raise that using this key here to the x power. And as you can see, nothing appears on my screen. We will fix that in just a moment. But I'll go ahead and write in my second equation of y equals $5,000. And we're going to see where these two graphs kind of cross. So I'm going to go ahead and zoom out a little bit. And just so you can see how I'm zooming out. So you can see, oh, there's my graph. Yay! I'm going to zoom out a little bit further. How much further until we get to $5,000? Alright, we can see it, that blue line and that red line. So I'm going to go ahead and use my fingers on my touch screen to kind of, on my x-axis, to kind of pull this out a little bit for my x value. And then I'm going to put my fingers on my y-axis to kind of shrink this down so you can see where that actually crosses. So as you can see here, they do cross, so I'm going to go ahead and put a dot where they do cross. So as you can see here, after about 17 years, the truck will be worth about $5,000. So we're going to record that onto our paper here. Alright, so that was about 17 years for about $5,000. So after about 17 years, the truck will be worth about $5,000. Let's continue on with part. Alright, so for part B, we're dealing with the value of a sports car at $45,000, which is going to decrease in value about 15% each year. They're asking us again to write an exponential function to plot it along with the previous example, we can. And then after how many years, the two vehicles, the truck and the sports car, will have the same value. Okay, so first things first, let's identify our initial value. So we bought this truck, or this truck was bought for about $45,000, so that'll be our initial A value. The rate will change to, which is 15%, to a decimal by dividing by 100. So go ahead and do that right now. And you should have gotten 0.15. So let's plug in some values, 45,000, and that's 0.15. So that'd be 45,000 here. Take a minute to go ahead and work out 1 take away 0.15, and you should have gotten 0.85. So on this next slide, we're going to go ahead and figure out, now that we have our function for this one, 45,000, 0.85 to the t power. So that's for this example B. For example A, that was about 28,000, parentheses 0.905 to the t power. So that was 28,000 and 0.905 to the t power. So again, we're going to use our Desmos.com to go ahead and graph these out and see where, when exactly both of these vehicles will be worth about the same amount. So going back to Desmos, I have the equation from my last problem. I can also type in y equals 28,000, or yes, oh, actually my new equation, 45,000, parentheses 0.85, close the parentheses, to the t power. In this case, we'll put it to the x power. So you can kind of see there's a little bit of a green and blue overlap. So I'm going to maximize this and see where they cross. All right. Again, I'm going to zoom in and see kind of where they cross. I can click and drag as well and kind of see where they might cross. Another way I can do this to zoom out is, because we have so many years, no one's going to own a car for 100 years. I'm going to go ahead and use my touch screen to kind of widen out my X value, so you can kind of see where those go. And then I'm going to also use my touch screen to kind of shrink down the amount of value so I can see more of the value on the screen itself. And I do notice they do cross. So I'm going to kind of just click and see that they do cross at about 7.5 years at about $13,000 or so. So about 7.5 years for about 13,115. Okay, so let's go ahead and do that. So they crossed at about 7.5 years at about 13,155. So after about 7.5 years, both of the values will be about the same at that amount. Okay, stop here and do the explain 3. That's in your packet, and we'll come back to go over the next section, B.